We wish to test the following claim at a level of significance of alpha of 0.01. The null hypothesis is that the population proportion is 0.9, and the alternative hypothesis is that the population proportion is less than 0.9. We have a sample size of 381 with 332 successes. We recognize that this is a one sample proportion, which has a test statistic of z equal to p hat, which is the sample proportion, minus what we're testing against, divided by the square root of p naught, 1 minus p naught, over the sample size. P hat in this situation is the number of successes divided by the sample size. So p hat is equal to 332 over 381, which rounded to 4 decimal places is 0.8714. So we have p hat 0.8714 minus p naught, which is 0.9, divided by the square root of 0.9, 1 minus 0.9 over the sample size, which is 381. Substitute, typing this in the calculator, 0.8714 minus 0.9 divided by the square root of 0.9, 1 minus 0.9 divided by 381 gives a test statistic of negative 1.861. We need to find this p-value. This can be done several ways. I'll go ahead and use the calculator. I know that this is a standard normal. We're at negative 1.861. Normal CDF, I'm going from negative infinity to negative 1.861. This gives a test statistic, a p-value for this region right here, 0.0314. Our p-value, which is 0.0314, comparing to the level of significance alpha of 0.01, our p-value is greater. When we have a large p-value like this, we fail to reject the null hypothesis. So there is not sufficient evidence. There is not sufficient evidence to claim that the population proportion is, in this case, our null hypothesis is that our alternative is less than 0.9, is less than 0.9. So we take our, we first find the test statistic, gives us a p-value, compare the p-value to level of significance, we reject the null hypothesis and write our conclusion. We can do this all in the calculator by doing a stat test. This is a one sample proportion test. This is number 5. The sample proportion in this case is 0.9. We had 332 successes out of 381. This is a left side test, and then calculate. We get the same p-value and test statistic here.